G'day chemistry students, this is the first video for module 4. In this video we're going to be looking at drivers of reaction. Essentially this module is all about energy and its role in chemical reactions. Now our first video is just generally about energy changes that happen in reactions and how we can talk about and describe them. Let's get into it. So first off, the best way to describe a reaction in terms of its energy is to talk about whether or not the reaction is releasing energy or absorbing energy to enable the reaction to occur. And these are known as exothermic and endothermic reactions, terms that you probably would have talked about all the way back in year 9 or 10. Now, if we're looking at the part of the term for exothermic and endothermic here, the thermic part, that's referring to temperature, and by extension, we can use it to talk about energy. Now, for an exothermic reaction, this term here, exo, means outside or external. And so, for example, we could be using the term or the prefix exo in the word exoskeleton, meaning a skeleton on the outside. Notice that then exothermic means that there's going to be energy on the outside. We could then take that idea and bring it into this idea of releasing energy. On the other side here, I have the term endo, the prefix endo meaning inner or absorbing. Thinking endoskeleton, any animal with a skeleton on the inside has an endoskeleton, so example, us as humans. Here, endothermic, meaning that energy is being taken in to enable the reaction to occur. So two types of reactions: exothermic reactions release energy, endothermic reactions absorb energy. Now, we've already started to talk about chemical reactions and describing them using energy profile diagrams. So here I have an example of an exothermic reaction in which energy is being released. So our reactants have a higher energy level than the products do, which means when they overcome activation energy, like we talked about in module 3, the energy drops down below the level of energy that the reactants originally had. And this difference here is the amount of energy that's being released as a result. Compare that to the energy of an endothermic reaction in which the reactants end up gaining energy when they form into products. What that means is that energy from external areas from the outside of the reaction is being absorbed and is a part of the reaction process. So the reactants will gain energy, overcome activation energy, and end up absorbing energy overall. This process here is endothermic. Something to note as well, when we're looking at any of our chemical reactions, the role of the catalyst can still be a really integral way to ensure that a reaction can proceed. And the reason that catalyst is so important is that the amount of activation energy, the energy required for the reaction to proceed, is reduced in some way, shape, or form, usually because the catalyst is assisting in a part of the reaction process which requires large amounts of energy. The example here that I used in a previous video for module 3 is that the catalyst assists in breaking the bonds of the diatomic molecules, which would usually require extremely large amounts of energy to achieve. Thank you very much, everyone. In the next video, we're going to be focusing on how we can calculate enthalpy change. Enthalpy is just another way of talking about energy changes in reactions. So we're going to be looking at how to measure those and do some calculations with them. But until then, have a good one.